Hey guys, I'm going to do a few of the examples from the worksheet. I'm going to go ahead and start with number 1. So it says the graph at the right shows a standard normal curve. For part A, it says what is the area of the shaded region? Well, the shaded region is below 1.5, so that means that your z-score is 1.5. So we're really looking for the probability that z is less than 1.5, then if we can either use the table or the calculator. If we use the table, we're looking up a z-score of 1.5. So I find 1.5 going down the row right here, and then the last digit would be 0, so right here. So I find where they overlap, and that is right here with 0.9332. So then the probability that z is less than 1.5 would be equal to 0.9332 or 93.32%. For part B, it says what is the area of the unshaded region? The unshaded region is the upper part right there. So to find the unshaded region, now the entire area under the curve is 100%. So the area that's not shaded would be the probability of z being greater than 1.5, which would be 1 minus 0.9332, which ends up equaling 0.0668 or 6.68%. Okay, so for all of number 2, it's asking you to evaluate using the standard normal table or a calculator and to draw a sketch to support your answer. So in these, because we're really just looking at a table for a value or using your calculator, your work is going to be drawing the sketch. So you need to draw the sketch. So in 2A, I'm looking for the probability that z is less than 1.45. So I'm going to draw the normal model by sketching the bell-shaped curve. Remember, your mean goes in the middle, which is a z-score of 0. Because remember, a z-score is how many standard deviations you are above or below the mean. So if you're at the mean, you're not above or below it, so it's 0. So if I look for the probability that z is less than 1.45, 1.45, that's positive, so we're above the mean. So that would be somewhere around here. So to find that, I'm looking that it's less than, so I shade below. And I can either use the table again, or I can use my calculator. If we use the calculator, you want to go to Menu, Statistics, Distribution, and then Normal CDF. Your lower bound is going to be negative 99 because most of the time your z-scores are going to be from negative 3 to 3. Most of the data falls within 3 standard deviations. So being outside of 3 is unheard of, but being to negative 99 is pretty much an impossibility. So this guarantees we're finding all of the area under the curve if we use negative 99 here. And then our upper bound is our z-score of 1.45, and then we just hit enter. We don't change anything else. And then this ends up giving us a probability of 0.9265 or 92.65%. And then that would be our final answer for that one. Looking at number 2E, we're looking at the probability that z is greater than 0.06. Okay, so this is a little bit different. So again, I want to draw the model. Again, the mean goes in the middle, which again has a z-score of 0. 0.06 is just going to be about right there. And I'm looking for the area above it. So it's probability that z is greater than that. So I'm actually looking for this area. Okay? So to calculate this, I can use the table. And I want to kind of show that. So if I'm using the table and I have a z-score of 0.06. So my first 2 digits are 0.0. And then my last digit is 06. So if I go all the way across and down, I'm looking for this value right here, which is 0.5239. Now, I want to point something out that what we're actually doing here, what this table is doing, is it's finding the probability below your z-score. we are actually interested in the area above the z-score. So the way to find that unshaded area, we subtract from 1. So what I'm going to do is to find this, if I use the table, I'm actually going to do 1 minus 0.5236, which will give me 0.4764, or 47.64%. That's if you use the table. If we use the calculator, it's the same thing. We're going to go to menu, statistics, distributions, normal CDF. But this time our lower bound is going to be our z-score. So our lower bound is going to be that 0.06. And our upper bound, since we're going above it, our upper bound, we would use a positive 99 here. Because again, we will never get to a z-score of 99, so that guarantees we find all of that area under the curve. And the calculator might give a slightly different answer, but it won't be off by much. I think the calculator gives you 47.61% instead, and that's okay. So let's go ahead and look at H. Here, we want to find the probability that Z is in between 1.91 and 2.93. So again, I draw the model. Here's my mean with the z-score of 0. 1.91 would be about right here, and 2.93 would be about here. And I'm looking for this area in between. So there are 2 ways of going about doing this. The first would be using our calculator, where 1.91 would be our lower bound, and 2.93 would be our upper bound. Or we can use the table. If we use the table, I'm going to look up both 1.91 and 2.93, and then I would subtract them. So if I use the table, I'm going to look up 2.93 first. So here's 2.9, last one is 3, so I go down, I go over, and I find out that it's 0.9983. And then the other one is 1.91, so I look for 1.9 and then 1, and I get 0.9719. So then what we're going to do is we're going to subtract those. So again, the probability I got for the 2.93 is 0.9983 minus the probability that Z is less than 1.91 was 0.9719. And then when I subtract those, I end up with 0.0264 or 2.64%. And then that's your final answer. Okay, lastly, I want to look at the challenge problem. I'm actually only going to do part A and then see if you guys can't figure out part B on your own. So this is slightly different. Instead of giving us the z-score, they give us a probability, and they're actually asking us to figure out what that z-score is. I said hint, use the table, and I'm going to show us how to do that with part A. So for number 6 in part A, I'm looking for the probability that Z is less than C, and I want to figure out what C is. So if I draw the model, okay, I know the mean is right here, okay, and if it was actually at the mean, 50% would be below that. But I know that the percentage below C is 17.36. And again, I know up to the mean is 50%. So 17.36 is about right here. So this area right here is a 0.1736. So I'm looking for this z-score, this cutoff value is what we call it, a cutoff value. So we're looking for whatever that value is. I know that it's going to be negative because it is below the mean. So when I'm using the table, that helps me limit where I'm looking because I know that I'm going to be looking at these negative values. So what I really want to do is I want to find the value 0.1736, so inside of the table. So inside the table, I'm looking for 0.1736. So if I look up here, I'm starting at 0.0003. So I'm going to keep going down. So I see 0.1s around here, And then I see a 0.1788, 0.1736 is right there. So if I use that and I go over, I get a negative 0.904. So that gives me negative 0.94. So that means then that C is equal to a negative 0.94. So that's my final answer. I'm going to leave you guys to try and figure out B on your own using the same idea and see if we can't come up with that. Awesome. I hope that helped. If you have any more questions about this, please feel free to email or come to the Google Meet office hours. That would be awesome. I hope you guys have a great day. Bye.